So nice to meet you all of you again. Happy New Year. Okay. In this semester, we will learn together the multivariable calculus. So this course actually, so we will always stay in these buildings. Your whole day class are in this building, right? Okay, no problem. Good. Then, actually, we're trying to find a TA. I will ask TA to come next week, so you can meet him. If you have any question, you can ask him. Okay? Because this semester I have 4 courses I have to teach, so maybe I don't have enough time to answer every email individually. So you can ask TA first, or if you meet me during the class, I will try to come early or leave a little bit late. So you can ask me during the class or in the break times. Okay. Indeed, if you really have a problem, you can contact me in Microsoft Teams or via email. Okay, but personally, I prefer Microsoft Teams because when you write the email, I cannot trace back what kind of question you asked before. If you ask me in Microsoft Teams, I can somehow review a little bit what is our previous discussion. This course, multivariable calculus, actually is strongly, if you say what do you learn in high school related to this, I will say geometry. So I think some students may be good at this, but some students maybe it takes time. So in this case, you need to follow me during the class, because when you control the robot, it's fully geometric, the 3D image. Okay, you should know how you can rotate the robot arm and do something. Okay, so in this case, it's very important, especially even you don't interested in robot, but I have some students do the 3D game with me before. But when you design the 3D game, you also need the formulas in order to calculate the density your target will go. Okay, in this sense, it's also multivariable calculus or linear algebra. Actually, you are lucky. Your first semester, that's linear algebra and multivariable calculus are separated. Okay, your previous senior actually learned all of them together, and then after that, they told me, okay, I don't understand what it is. It's so messy in the mind. But to be honest, the same as me. Okay, so I don't understand linear algebra until my PhD degree. I just don't know how to calculate this. But actually, what is this? I don't understand. Okay, but I try to explain to you, make you can somehow make sense what is when applied in the real world. Okay, then this one is majority of the content that we will do. Okay, so we still in this week and the beginning of next week we will somehow review a little bit what you learn in linear algebra, because linear algebra when they in 1D, 2D, 3D is strongly related to so geometry. But when you go to high dimension of linear algebra, then it's related to the calculation. Okay, they try to speed up your calculation. So you have learned linear algebra in probability, okay, and also regression, and also in linear algebra. Later you will learn it in machine learning and AI related course. You will know when you deal with the big data, it's impossible for you to calculate based on what you learn in statistics, okay? Because the burden in order to calculate will increase a lot when you have a lot of data in hand. So in this case, you have to use linear algebra or geometric, or what's called multivariable calculus will speed up your calculation. So you might well get the perfect or the best solution. What you get is one accepted solution that's very close to the best answer. Okay? That is our goal. Then make sure this course, the prerequisite is calculus 2. Indeed, you may saw some place mention linear algebra, but I ask them to remove. So this course don't require linear algebra as a prerequisite. I don't know all of you passed last semester or not, but anyway, if some of your friends did not pass linear algebra, you can inform them they can attend this class as well. Okay, this based on the meeting last week, not last month. Yes, the end of the December. That's all I asked them to remove. Okay. Okay, then this one is the content. Basically, any calculus. So it depends on if you go online to search multivariable calculus. Maybe you cannot find the related course because multivariable calculus somehow will be integrated in calculus. So you will have calculus 1, 2, 3. Multivariable calculus will be calculus 3. Okay? So if you want to search some online, okay, document, search either calculus 3, okay, or multivariable calculus, or you can try to Google the topic, okay, then you can get some related content. I highly recommend you to do more exercise rather than you got in what you learn in this class, okay, in order to prepare the exam or to master what you really learn. You even can ask ChatGPT to give you some example question that's related to this topic that you to try. Then you can learn step-by-step solution. But don't try to give your question to ChatGPT. I try. The answer I cannot use at all. Okay, so be careful. Okay, so but the question ChatGPT generate by itself or give you a solution step by step usually is correct because they will have some reference in some document. Okay, but don't ask them to help you to solve the question. Okay. Then the other thing are quite similar as discrete math or probability statistics. So all my announcement I will try to inform during the class or in my course view. Indeed, please follow my course view because it will be most updated. Because sometimes if I make in class, will be only 1 month before. If I change anything, I will inform in my course view. Then homework and exercise, the quiz. Okay, so you should submit on time. As I mentioned before, I only require 60 to 70% submission or accuracy, but anyway, I will sum up everything. So if you pass 60 to 70%, you will get full mark. Okay. Then, and if you have anything about the grade, please contact TA. Okay. I don't have regular attendance checking, but the same as before, I will give bonus if you attend. Okay. Then the homework bonus 40%, 14%. Okay, I will give 2 quiz. So quiz 1 and quiz 2. So in this sense, it's 8 per each. So total is 16. Okay. Then midterm exam 30%, final exam 40%. Any question? Okay, the same as before. I cut only when there's some gap between your score. So I cannot say if you're more than 80, you will be for sure A. I just can guarantee, based on my experience, if you're more than 90 and 20% top, you will for sure get A. Okay, but usually I will lower down this requirement a little bit. I just see where there's a gap here. But if, okay, so you know my if is you cannot missing midterm and final without any official reason. That is mean you need a committee to approve your absent. Then if your total score less than 50, you will for sure get fail. But if you above 50, usually I will try to give you C. But sometimes you may get D or D plus is when you have a big gap. So other students are something like 60, 65 plus, but only you like 55. So then I cannot help you. I must downgrade you. Okay. So in this sense, be careful. After that, this one is the schedule of the class. So here I'm mapping some content in the textbook. I use actually I don't 100%, but I like this book. It's somehow easy to read. Okay, so you can go whether you can refer here or not. But sometimes what I teach is outside of this, but sometimes I remove some difficult thing from here. Okay, but you can reference this book. It's very old book, but I don't think it's changed much. Okay, for calculus. So you can download this. But this one include calculus 1, calculus 2, calculus 3. So major in this courses is from chapter 11 until chapter 15. Okay, no problem? Okay. Okay, here. Then I think in total we only have 13 times because 17 minus midterm and final, then there's 2 holidays on Wednesday, so only 13 times. So make sure. Then to quiz time already fixed, so somehow you need to be careful. Okay, so February 5th will be the first quiz. So the same thing, my quiz will be not very long. Okay, so somehow short, just some basic understanding. So 1 hour quiz. Okay. No problem? Okay, so the other thing will be the same. So today we will go to study the actually it's the review content. So just to review a little bit what you have learned in the last semester, linear algebra. Okay. So at here I very highlight the geometry. Okay. So because later you have to do some line integral, surface integral, volume integral. So in this kind of thing, if you cannot image the 3D in your mind, will have some problem. Okay. So in this case, somehow pay attention. So the first start, we have 3D coordinate system. Okay. So in this sense, I think you have learned is that x in 3. Okay, x in 3, x equal to 3. In R, this one is R powered by 1, one-dimensional space. R2, two-dimensional space. R3, three-dimensional space. No problem about notation. Okay, Rn, then is n-dimensional space. Any question? No, right? Okay. So this one, can you ask me? If I will show a relationship about maybe baga. Okay, there's no pen. Okay, let me try. So if we have this y equal to x1 plus x2 plus x4 or x3, can you tell me this relationship, if I want to show it, the relationship, I need how many dimensional space? 3? I show the relationship. This equation show the relationship between what? Between x1, x2, x3, and y, right? Okay. So in this sense, how many variables here? 4. Okay. So you need 4-dimensional space to show the relationship. Okay. No problem. Then the other one, why we have to learn hyperplane? I think you heard this name in linear algebra, right? Hyperplane. Why I need to hyperplane? Hyperplane equal to what? Minus 1. No problem? Why we always learn a minus 1? This one, 4 minus 1 equal to 3. Why? Because you usually always have one what? Dependent variable. You always have one y. You say y, how it depends on x1, x2, x3. So you have independent variable number usually equal to minus 1. So minus 1 usually is what? Your domain. How you define in this equation based on x. Okay? then y is your dependent variable. So in this sense, when you count, show how many space you need to visualize, you need to count all of them is the key. Okay? No problem? Okay? Then m minus 1 is used to show the domain. Okay? Okay, this one is here. Then after that, when m minus 1, r1. Okay, so when r1 that is mean you only have one variable. One variable, that is mean you equal to have one axis. Okay, so you have to, sorry, I forgot one thing is, this one you should draw an arrow because it's an axis. Okay, you will have one axis. So in one axis, what do you draw? This one easy to have a mistake is you will you will draw one line. No, in one axis, smaller than line is that. Okay, so x equal to 3 in R1 is a point. Okay, no problem. Okay, it's a point. Okay, it's here. But if you in R2 you will have what? Two axes. So x and y. Indeed, you show this one x1, you show this one x2 also okay. So axis notation is fully depend on you. Okay, just you use small letter. Okay, small letter. So in this sense, x equal to 3. So this one, when you have two axes, two arrow, then you can expand on what? A whole plane. Okay, whole plane. Then when you fix one x, so that is mean y is free. Okay, when y is free, that is mean you fix one axis. So 2 minus 1 equal to 1. So R1 is what? R1 is a line. Okay, R1 is a line. So in this case, x equal to 3 in two-dimensional space is a line. Okay, no problem? Okay. Then the same thing, if you think 3 dimension, they have x, y, z. You say x equal to 3, so you fix one dimension, but you still have 2 dimensions are free. Okay, so in this sense, 2 dimensions are free, then 2 dimension space is a plane. Okay, no problem. So this one is, I want you to get it from, okay, what you learned before. Okay. Then, as we say, this one, if we show by an equation, okay, so this one you need to be careful is the one for coordinate, okay, for all coordinate. What we want to show is a vector, okay. The vector, be careful, is a distance plus a direction, okay. But a vector can be in any dimensional, 1 dimension, 2 dimension, 3 dimension, n dimension, okay. So that's mean in R1 you also can have a vector, okay. So you have 3, but indeed your unit, okay, so your unit vector is only EX because you only have 1 dimension, okay. So EX, indeed 1 axis, so that is mean the basic vector only have 1 input. So it's what? It's a 1 a vector, okay. It's also a vector. So time together you will have what? 3 vector, okay. So this one is shown in positive direction, you will have 3, the same as the unit vector 3. Okay. So be careful, this one you cannot roll 3 only because this one is a vector. Okay, it's a dimensional space. Okay. Any question without this? So if you write the first one is wrong, the second one is correct. Okay. Then in R2, okay, R2, 3, usually you will have 2 axes, okay, 2 axes, so EX and EY, okay. So at here, I only say x equal to 3, but I did not tell you y. So y at here is a variable, okay, y is here is a variable. So in this case, when you roll, you can roll what? When you sum together, you will roll. EX is what? 1, 0. Okay. Then EY is 0, 1. Oh, sorry, I timed wrong. So I should reverse. Sorry. So this one you need to time in front. Okay. 1, 0, 0, 1. Okay. Because it's roll time. Let me remove it. time front, because you will be row time colon, row time colon. Okay, so these two will be equal, because you will say why this one you wrote 3 times ex, not ex times 3. Is the same or not? 3 times ex times 3. A times a vector and a vector times A. It's the same, right? So that is mean a normal number times a vector, you can time from, time back is the same. Okay? But just if a vector times a metric or metric times back metric, they are different. Okay? So in this one, so you can write like this. So in front is the basis 1001 times 31. You can write like this. So this one is what? Is I. Okay? That's what we say. This one equal to I. Okay? Indeed, you can write, to be more specific, you can write I2. Okay? Because I1, I2, I3, they're different. Because the number of input, they're different, they're not equal. Okay? So time 3y. So this one actually equal to what? 3y. I times anything is itself. Okay? I times a vector is itself. Any question? Okay? So you will have 3y. 3y in the image, if I told you is what? It will be x equal to 3 or y is allowed. Okay? If I say like this. So this one more specifically, you have to write like this. Okay? Then this one, the third one is 3 dimension. You have ex, ey, ez. Okay, 3 axes. But be careful, this one ex will be what? 1, 0, 0. Okay? Then ey is 0, 1, 0. Ey is 0, 0, 1. Okay, so how you say the unique? Okay, the unit vector. Then you times 3. You told x equal to 3, but y and z you did not mention anything, so you will carry 2 variables. Okay, so these 2 variables, as I defined before, they are any real number. Okay, so in this sense, similar as in R2, you can write the vector equal to 3yz. So if I wrote 3yz, you should know, okay, this one is a plan. Okay, it's a plan. So far, okay? Then we talk about the 3D coordinate. Then we move a little bit, okay? The vector arithmetic. So how we can plus the vector together. Okay, I think it's the first chapter that you also learn in the linear algebra. So in this case, any r. So at here, this one is r. Okay, so any r. So that is mean if I have a r0, okay, then we have a. So what you will do is you should put what? R0 and A link with each other. So that is mean the head of A link with the tail of R0. Okay, continuously. Then from the head of R0 until the tail of A, vector A will be what? Will be their sum. Okay? Any question? No, right? Okay. So in this case, actually I can draw. How to sum these two? How to sum these two? How to sum these two? Head on. Can I do this? This one is correct? No. Okay, this one is not correct. So when you do, you have to move what? This small one into here. Okay? Then sum here. This one is the sum. Now tell me, what's the meaning of this equation? Why I need to sum 2 vectors? What I need to sum 2 vectors? What's the meaning of here? What's the meaning? The simple one, the real implication is the force. Okay? So you have 2 force. Okay? Then you want to know. So the item is idle, this one is idle. I have force to push here, I have force to push here, but actually how is moved? They move front. Okay? So in this one is you can simplify the force, the system, everything have a direction. Then or other thing like velocity. Okay, so you consider velocity, they have a direction here, have a direction here, they may be turn around with the rotation. You can see I do a ball like this, shrink like this, they will turn around. But when you analysis the force, there will be the velocity is will be different. So this one is here. And also you can analysis how to say the movement of the robot. Okay, so as well based on this, because you have to analysis the velocity. Okay, so you will see in which direction the robot will move. So this one maybe is the this one is the original. Okay, the original. But the add-on, they ask this one to remove from this direction. So how we can, okay, so which direction the final move, okay? Or usually what we calculate is not calculate plus in your most of the robotic project. Most of your robotic project actually is calculate A, okay? Because you will have the current direction and the direction you want the robot to go. Okay, so in this sense, you have to use what? The density minus the original, then you will know what is A. Okay, so in this sense, it's the similar thing, but you have to know what should they apply in the real scenario. Okay, any question? No, right? Okay. Then, no matter you do what, if you like this, if you want to know A, then you will have X, Y, Z, as I say, X, Y, Z. Okay, so you use X, Y, Z minus X0, Y0, Z0. Okay, so the T is if your A given by a unit vector. Okay, this one show a direction. Okay, so then this one is how many states you have to go. Okay, so you can treat ABC as a base vector. Okay, to show it's in this direction, the unit is like this, how it can work. Then X, Y, Z will be equal to, so just a vector, how they T multiply inside and sum together. Okay. Okay. Then, give you some time, 3 minutes. Okay. Think about how to solve this one. Try. Okay. You maybe cannot remember, but not force yourself. It's just a recover. Be careful. This one is define a line. Okay. And here is a line. It's not a vector. I hint give to you is vector have no location. Vector have no location. Vector just a direction and size. Okay. But a line has location. So the vector, if need a location, we need to define what? We need to define the starting point. So a point with a vector, you can show a line. So the point, the answer later I show you may be different because you can pick up any point in the line. How to show vector? I give you 2 points. So define a start and end. Any different? I use first point minus second point, or I use second point minus first point. Any different?
No.
Itself has difference because it's reverse direction, right? But when you mean a line, actually not much difference because it's just the K. You choose positive or negative. Okay? But when I say these two vectors has the difference itself, yes. Okay? But when you define, no. So you define a vector, you use usually I used to use second one minus the first one. Okay? Then I will use the first one as the start point, but actually you use second one as a start point, also the same. So the first one is like this. Okay? So vector form, no matter is a line, is a plane, is anything, you can show by a vector. Okay? A whole space 3D is combined with a lot of vector. You don't need to think this side, the left side, what should be is a vector. Okay? Because it's a line. Personally, I like to carry the variable. If this equation have variable t, I will say it's a vector depend on t. But if you have it's a plane, then they may have 2 variables. Then I will say t is here. Because it's just mean when you see how many variables you have, you will know this one is a plane or line or nothing. Okay? If you have no variable, this one is a point. 1 variable, this one is a line. 2 variable, this one is a plane. Okay? Then this one, okay, the vector, then t time what? The ending minus starting. Okay? Then you will have something like this. Indeed, here I forgot. T should be in, you need to define the t as well. Okay? The r, the real number. Any question? Okay, so you don't remember what is vector form is okay, but you should be able to read this one, what is the meaning, and the next time when you do it, you should be able to do. Okay? No problem? Okay. The same thing, if it's a plane, what will be? If it's a plane, will be what? 2 points, define a line, right? Define a plane, I need what? 3 points. Okay, 3 points, so no problem? So this one will be what? If I give you the other, I don't know it's correct or not, but I use the other one, 1, 1, 1. I say a plane need to plus 3 of them. If I give you this equation, what will be? Then you need to plus 1 because this one is 1 vector. Okay, 1 vector only show 1 direction, but it's a plane. You see, when you define a plane, you need a origin and 2x and y, 2 axes. Okay, so at here, you only give 1 axis. So how to see is a point or axis is that a point in front don't carry a variable. Okay, because this one is mean a point in front, no variable. So that's one is a definite point. But second one carry t, so that is mean this one can be used as an axis. Okay, so the second axis is what? You can define, maybe use, if this one is the original point, you use 1, 1, 1 minus 2 minus 1, 3. Okay, then time s. Okay, so no problem. This one you will say RTS. Okay, be careful. This one you need a vector. This one is the same. I don't repeat. Then you plus. This one is the same as the question. Plus s. Because this one s is meaning the other direction. You need 2 axes. Okay. Then here you wrote 1 minus 2. 1 minus 1 and 1 minus 3. So this one is a plane. Okay, no problem. So define 3D. How you going to do? You need what? A point with what you need to carry 3 variables. Okay. Okay. So then you need 3 axes, 4 dimension. Can you show 4D with 3 entry vector? No. Okay, because the maximum only 3. Okay, so no problem. Okay. Okay, after that, parametric form. Okay, parametric form, indeed I wrote under that parametric is what? I define equation for x, I define the equation for y, I define the equation for z. Okay, no problem? So, based on this, this side, the r, we can write as what? We can write as x, y, z. Okay? So this side I can write x, y, z. This vector is x, y, z. Then x, y, z, I sum this one inside. X will be equal to what? 2 minus t. No problem? Okay? So this one wrote x, y, z because all 3 and 3. Okay? The right hand side, please calculate this one. Okay, calculate this one, sum together. Okay. Then when you wrote, you cannot write vector form, you should write as 3 different equations. Okay, 3 different equations. Indeed, the same. Define t. Okay, I forgot to write t. T is in real r. Okay, real number. So no problem if I, in the midterm, I ask this kind of question. Okay, so you should in different form. Okay, so the next one, symmetric form. Symmetric form. What is symmetric form? Any common vector here? What is a common vector? Why I have a parenthesis here? Because I need to satisfy 3 equations at the same time, right? 3 equations, the t in 3 equations should be what? Equal. No problem? Equal. So please rewrite every equation that's related to t. The first one, t equal to what? 2 minus x. Okay, actually divide 1. Okay, then the second one, t equal to what? Y plus 1 divide 5. Okay, so all t, you can get t equation here, t equation here, t equation here. Then all of them equal. Okay, so this one means symmetric form. Okay, any question? Okay, this one means symmetric form. Any problem? So I remove the variable out. The t should be equal to each other. Always the under one. You may say, why I always need to divide 1? Divide 5, divide 6. 1, 5, 6 is what? Is the coefficient in front of t. Okay? Okay, so this one is here. Okay. Then, based on this, we have general form. Okay, general form. General form actually is easy, but be careful. This one, I need 2 general form. Okay? Because if I write one equation, so I can reduce what? Tell me, if general form is what? Ax plus yz over plus by plus cz equal to d. This one is general form. Can you tell me this one mean what?
Equation of a plane.
Yeah, good. Okay, this one is the plane. Why? You have x, y, z. X, y, z is what? How many dimensions? 3. Okay, 3 dimensions, so R3. One equation reduce what? 1 dimension, because you can write z equal to something, or y equal to something, or x equal to something, but you can only choose one as dependent variable. So one equation only can see one variable, how they defined by other variable. Okay, one equation reduce 1 dimension. So that is mean this equation, this type, is always equal to hyperplane minus 1. Okay, so this equation is one plane.
But now I need to define a line, how it will be. Then I need to define what? I need to reduce one equation, reduce one. So a line is what? You need to reduce two variables, right? Okay? So in this sense, you need what? Two plane. Okay? So line usually is what? An intersection of two planes. Okay? They need to satisfy two planes together.
So, how to find two planes? Actually, you can get from the what? The symmetric form. Okay? You can either pick up two of the equation. Okay? This one can show the relationship. Okay? So you just based on this, you pick up these two, or any two of them. Okay? Just not pick up the same. Okay? Sorry, I forgot to define it movable. What is that? So in this sense, we just pick up any of them. So I can roll in this kind of form, but I just put 9, the D, you can put the left and the right, actually it's the same. Then you will ask me, where is Z? Where is Z here? Where is Z in first equation? You say it's a plane. Where is Z? Where is Z here? There's no Z here, right? How to make Z disappear? If I need to add on a Z here, how I can add? What's times Z equal to nothing? 0. Okay? So that is mean you can add Z here. Okay? You still have X, Y, Z just in front of Z. Z can be any variable because a coefficient is what? Is 0. No problem? The second one also, and here you also have Y, is just in front of Y, you have a coefficient 0. Okay? So that is mean in first one you can define Y very clear. You can write Y to be an equation between X and Z. Okay? The second one you can define Z. Okay? By what? By X and Y. Okay? No problem? Okay, this one is a line. Okay, so because this one is very critical. Later we will have something like line integral. You have to integrate something according to the line. But if you cannot define a line clearly, then it's no way for you to integrate. Okay, so in this one you need to be careful. Okay, the next one. You define a line that passes through the point. Okay, this one is a point for the line. You got a point, good. Okay. Then they already told you this line is parallel to another line. Okay, this one is another line. Then they give something like this. Okay. And the line, so this one actually give a direction. Okay, because it's a parallel. So they will say this one passing through, what is XY plane, XZ plane? What is XZ plane? XZ equals to 0. XZ plane is mean XZ is free. Then Y equal to what?
0.
Okay, Y equal to 0. So be careful, okay? XY plane is XY is free, Z is 0. Okay? Okay.
So first, this the line is the second line. Sorry, I think I need to type this a little bit.
Okay, I should give the second line. So first, okay, at here you need to define the second line very clearly. So you should reorganize. Okay? Oh, sorry. I think I typed. Oh, should be 1, 0. Oh, sorry. Not the second line. This one is the first line. Yes. Oh, thank you. You're so good. I love you. Okay. Okay, thank you. You saved me. Okay. But where to write? Okay. We have XYZ. Okay, so XYZ, the first one we need to roll 10. Okay, 10 plus t variable. And here we have 3. Okay, this one is x. Then y is 12t. So the point is 0. This one row 12. Okay. Then the next one, this one is minus 3. Then the t is minus 1. Okay. So they will pass. The line that we want to get is parallel to here. This one shows the point, location, as I say. This one shows direction. Okay, this one shows direction. So that is mean parallel. That is I don't combine the location. Okay, so I only care about the direction. So what I need to get is here. Okay. Then the point of the line that we want, I already give you 0, minus 3, and 8. So we will have here. No problem? So the line is the point. Okay, I use the point that we give. Okay, then give you a direction. Okay, because line you can move any parallelly. The vector you can move everywhere. Okay, everywhere. So no problem, free to move. So this line will pass XZ plane, will pass a plane when what? As we say, when y equal to 0. How to see? If y equal to 0, we can calculate what? T, okay? So when y equal to 0, we can calculate t. Okay, so t equal to 1/4. Okay, no problem, right? So if you know t, you can define a point. Okay, okay, no problem. Okay, so you will have here. Okay, I feel I always forgot to write the. Forgot to write T is free. It's not a good manner. Okay, so I try my best because you need to define the variable. Okay, then we study about the line. Okay, line finish. Then we come to the plane. Okay, plane. Rather than, as we say, this one you be careful the define. I feel.
Thank you. think until now I give you a summary. When you define a space, okay, you be careful. There are two things. Okay, the first thing, a coordinate. You always need a point because you need a start point. Okay, a point. A point with one vector is a line. Okay, two vector is a plane. Okay, three vector is a 3D dimension. Okay, four vector you cannot visualize, but it's four-dimensional space. So you have to see how many vectors that you have. Okay, okay, no problem. Okay. Then after that, what I need you to remember is when you have ax1 plus by1 x2 plus cx3 equal to d. Anything? Be careful is that one equation as you wrote, you can reduce one dimension. So this one is the key so far that we learned. Then the next one, we have a normal vector of a plane. Okay, normal vector of a plane. So in this sense, you will have n dot product something. What does this mean? So we can see in this graph, r minus r0. This one is mean what? Be careful is that if I say r0 when I show is what? We use R0. This one is, if it start from, this one is origin. Okay? So this one R0 is mean the end point is in the plane. Okay? So does not mean R0 vector is in the plane. No problem? Okay? When we show the location, only show the end point is in the plane. Okay? But R0, this vector and P, I will show what? They will use the same x, y, z. Okay? So R0 also x0, y0, z0. P also x0, y0, z0. No problem? Okay? Because R0 will show the location of the end point because we consider the starting point equal to 0. No problem? Okay? Then you will have R vector. So the same thing, R vector x, y, z. But R vector, this vector usually will not in the plane. Only the end point will be in the plane. Okay? Okay. So in this case, I will say two of the end point will in the plane. So I need a vector in the plane. That will be what? P minus P0. Indeed, you can also P0 minus P. But usually we carry 0 is mean I want to use this point as what? Origin. Okay? So that is why we use P minus P0. Okay? So a vector. So that is mean R minus R0. So this vector, normal vector is what? This one is vertical. Okay? So vertical with the plane. Okay? So in this sense, the dot product, okay, if it's a 90 degree, the dot product of anything, this one with any vector on this plane will be what? Will be 0. Be careful, dot product you will get 0. Cross product you will get what? A vector. Okay, a vector. So dot product always get a number. Okay, always get a number. Okay.
But indeed, you only need to remember dot product equal to 0 or not equal to 0. This one only. Why we care about equal to 0 is that we want to know this one is there's vertical to each other or not. Okay, so no problem. Okay. Then A, B, C is the normal vector. Dot product time. Okay, so x, y, z. So usually x0, y0, z0, this one should be given. Okay? Okay? Because if I give the footnote, it means this one has to be fixed. Okay, this one is origin. Then x, y, z is any variable. Okay? The product equal to 0. Then you can carry on what? Okay, ax times this, okay, times this equal to 0. Okay, dot product. Okay, this one be careful. You cannot write ax minus x0 equal to 0. Okay, you cannot do that. I feel someone will write a parametric form, 3 of them. No, this dot product, how to calculate this, you need to be careful. So this one, how many variable here? How many variable? 3, okay? Only x, y, z. As I say, x have a footnote, is a number. They must be given you. Okay, this one have to be fixed. Okay, so x0, y0, z0 is not variable. Okay, so this one should be replaced to be a specific number. Okay, a specific number. So when I use the normal form here, the normal form here, actually if you time together, this one will be what? Very similar to a general form of a plan. Okay? Because you can write x equal to something else, y equal to something else. Okay? Because d will be equal to what? D will be equal to ax0 plus by0 plus cz0 is d. Okay? Okay. So very similar to the previous question. Now I wrote what? I asked you to write an equation for a plan. But here I have a vector, normal vector form. Question: why line have no normal vector form? Why line have a no normal vector form? How many normal vector we have for a plan for a line? What? In a 3D, I have a line. I am a line Z. I'm a line Z. I'm a line. I do vertical. How many vector vertical to me? Yes, the whole floor, right? So the whole floor are vertical to me. Okay. So that's why in for line I don't show normal vector form because I can find infinite. I don't have a direction. Okay. So in this one, be careful. But if in 2D, a line have a vector form or not? In 2D, yes. Okay, in 2D has, but in 3D no. Okay. So the same thing, vector form, I think I already explained. Use any point as origin. Okay, so usually I choose the first one, P. Then a plane needs 2 directions. So if you choose P as start point, usually I will choose P, Q, or PR. Okay? No problem. And in front, I like to write TS. Because when you carry variable, indeed, if you only say R, I will not R vector. But if you say R, I will give you a wrong. Okay? So this one is a level. So you write R. This one means what? A number. So for sure you will get wrong. Okay? R, T, S, you will also get wrong. Unless you wrote this one. Because this one is very hard to read. You can use a bold. Write bold. Okay? Bold also can show a vector. Bold letter. So B-O-L-D. Okay? This one is okay. This one is okay. But because this one you're very hard to write a bold, because I usually cannot separate you write bold or not. Okay? So that's why I require you carry an arrow in front. Okay? So you write like this, or you write like this, or arrow, I'm all okay. Okay? So this one okay. Okay? But the best answer is okay, this one or arrow, so no matter how you write. Okay. I prefer this one. Okay. But this one acceptable. This one also, these 2, these 3 are correct. Okay, you don't carry variable.
But these two I will give definitely wrong because you cannot separate it's a vector or non-vector. Okay, it's a totally different thing. Okay. But this one depends on how careful I will read it. So if you did not draw significant, I cannot read, then it will be wrong. So I recommend to write these two, but this one is the best answer. Okay? You better carry variable. Okay, then I can know you mean a line or plan. Okay? The next one, normal vector form. How to find a normal vector? I give you a plan how to find a normal vector. Inside, what are on the plan? What are vector on the plan? 1 minus 2 and 0 is in the plan. This one is in a point, right? Right? This one show the point on the plan. A point on the plan, when I show a vector mean a point, they start from what? Start from origin. Okay? So, the first one, please don't use the first one. The first one is not in the plan because it means a point. A point usually start from 0, from origin, and end at this point. So this one, the point only show the ending point is in. Okay, does not mean the vector is in. So what are two vectors on the plan? These two. Okay, because these two, both P and Q, P and R are on the plan. Okay, so you just find the ending two, but be careful, it cannot be parallel. Okay, if you find two parallel, it has no meaning. Okay, non-parallel is somehow check. These two is not parallel. Okay, then fine. Okay, then fine. Then you know 2 points. How to know the normal vector?
Cross product.
Cross product. Okay. Then how to do cross product? Okay. Indeed, I have no way, but I allow you use calculator. Okay, I allow you use calculator in the exam. Okay, because this one is not I require you, because anyway after you finish linear algebra, when you have cross product, no one use hand. Okay, but you should know is you should tell. Okay, the equation you should use the cross product. Okay, no problem how to calculate cross product in a calculator. Please learn by yourself. Okay, because I also not quite good in to use calculator. I only code in Python and other. Okay. Okay, but review a little bit how to do cross product. Cross product when you wrote, okay, IJK no problem. IJK no problem. Show three of them. Then you have vector 2, 3, 4. 2, 3, 4. The other one, minus 1, 1, 2. Okay. Indeed, how to time? Basically, I feel the most easy one is N1, 2 row. 2 minus 1, J 3, 1. Roll again. No problem. Roll again. Then, when you calculate this, always use right. Okay, right hand 2 row. Okay, 2 column. So this one is what? Okay, so maybe I use dash. The real line. So 1, 2, 3, 2 minus 4, 1. Then you will get what? 2, right? 2, right? No problem? 2, right? Okay. Then the next one. This one. This one you will get what? This one. You will get the same. This one, this one. So 4 times minus 1 minus 2 times 2. So minus 8. Okay, no problem. So this one, the K, the same. These two, okay. So 2 times 1 minus 3 times minus 1. Okay, so then you will have 5. Okay? Okay? So this one is just a review. If you will have to calculate manually, it's like this. But I think in the midterm, I will allow you to use calculator. Okay. Okay. Anything? The question. If cross product equal to 0, mean what? Cross product can equal to 0? Cross product can equal to 0 or not?
Yes.
Yes.
No. Why?
Oh,
0 vector.
Zero.
Okay. Okay. So be careful. I very highlight 0 and 0 vector. Okay. Equal to 0 vector mean what?
They're not linearly independent.
Yes. So they are what? If by geometry,
Parallel.
parallel. Okay, they are parallel. They cannot cross. Okay, they cannot cross product. Okay, so they are parallel. So 2. Okay, so about product equal to 0 is mean vertical. Okay, so if a cross product is mean parallel. Okay. So the normal vector form, you have a normal vector, then what? Normal vector time a vector in the space. Okay, so on the plane. So on the plane, that is mean what? Any point minus the origin. You can pick up any point as origin. Before I already pick up P, here I pick up P again. Okay? So 2 minus 8, 5 dot product x, y, z minus what? Minus P. Okay? So that is mean. But indeed, they say minus Q is okay, minus R is okay. Sure, you can pick up any of them. Good? Okay. 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 So, and after that is a scalar form. Scalar form, be careful, is different from parametric form. I did not ask you to write parametric form, but you can write parametric form again. Okay, so you can write each of them down. Based on this, you can write parametric form. So x equal to 1 plus 2t plus minus x. Okay, but scalar form is extend. Okay, extend here. So 11 dot product out. Okay. Then organize it again. So to be like this is a general form. Okay. So you can write parametric form, but be careful. You can write the parametric form only based on this. Okay. So actually you have the parametric form. Okay. So be careful. Okay. Because I have no space, so I try to save it. Okay. But if I ask you parametric, be careful, you need to define vector form first. Okay. Okay, no problem? Okay. What's the time now? Okay, time. So it's fine. I can continue. So now is a go back, is a review. Okay. So somehow about vector geometry. So now, what is multivariable calculus? Until now, the calculus you learn is related to x, y. Okay, x, y, maximum x, y, e, z. But multivariable calculus is that you always has more than 2 variables. Okay, so at least 3 plus variables. Okay. So in this one, equation, what do you learn in calculus? You only touch this one, z equal to fxy. So this one is defined. Z is based on what? A function of 2 independent variables. So be careful. Independent variable is xy. Okay, z equal to xy. So be careful when I visualize the whole relationship, I need to use 3D graph. So separate, one seat here, one seat there. Or if you want to see together, carry this one. Okay. So here,
you will have, okay, so this one is what? In total variable, x, y, z, x, y. So this one will be, if you visualize, you need 3D, okay? You need to 3D visualize the relationship. So you can define z based on the x, y. I have a question. Whether this one is for sure a plane, whether this one for sure is a plane, because linear algebra, if in linear algebra this one is a plane, okay? But linear algebra, they have a word linear inside, so that means the equation is linear, okay? But now fxy, they say this one is linear or not? No, right? No, right? How to define a linear? X cannot be power, okay? But in this fx equation, can I say x squared, ax squared plus y, or 2x squared plus y, okay? This one also 2 variable x and y, so no problem. So be careful is that this one is not a plane, okay? But this one 2 variable, later I will tell you this one for surface, okay? A plane and a surface, okay? A plane is a flat, it's a linear, but a surface maybe have a curve or variable dimension, okay? So we call x, y is independent, z is dependent. Be careful many times. I think I highlight many times, but when students answer me in the machine learning course, they still confuse these 2 words. Independent is mean what? External, okay? Not defined by your system, no problem. Independent is external, is by given, okay? It can free change outside. Dependent is dependent in the system, so it's internal variable, okay? So that is mean x, y independent is I need to give you this value, then based on this you can calculate the z value, okay? Then I ask you that. This one, which one is dependent, which one is independent?
If it's arbitrary, you can make anyone.
Yes, you can make anyone, okay? But usually you can random pick up anyone, okay? Random pick up. But if it's like this, z equal to fxy, if they wrote like this one is mean they already pick z as dependent, xy as independent. But here, depend on you, okay? But I say depend on you. In practice, you need to find which one is easy to get. Okay? If you more easy get x and y, then you pick up z as a dependent. Okay? But if it's y is more easy, you need to get the other one. Okay, other 2. Okay, so in this case. Okay, the next one. Equation of the form of W. Okay, so W, X, Y, Z. This one is how many dimensional space?
4.
4. Okay, 4. Can we visualize it? No. Okay, so we cannot visualize it. Okay. So indeed, you can go 5, 6, 7, many, but the problem is we cannot visualize. So, but related to robot, you basically go here. Okay, but if it's 3D, okay, if related to robot, basically you go 3D. But if you want to study AI, okay, big data, then it's go far away. Okay, so in this sense, separate 2. Okay, so that is why I keep highlighting. Okay, then this one we will have 3 independent variable. Okay, so 1 dependent variable. Okay. So at here, but usually in this one we can go. Then you will say 5 variables, 6 variables, 7 variables. They are all multi-variables. Okay. Okay. Then if I say, okay, so z equal to fxy of variables, also that is mean z depend on what? A pair of xy, okay? So in this sense, as I say, it can be either plane, okay? So plane is mean this equation should be linear, okay? You will have no square, you will have no exponential, you will have no log, okay?
So to be like this, okay? And you will have no dy, okay, or anything. But here, if you have no powers, not linear, so this one will be here. So this one is elliptic paraboloid, okay? So in this case, this one we call surface. Okay, surface. We will not call a plane. Okay. So this one actually you say plane is a surface or not? Yes. Okay. Plane is a linear surface. Okay. Then if it's a line is VS we call curve. Curve. Line is a special curve. Okay, so from now on, we go extend from linear algebra. I will call curve and surface rather than line and plane. Okay? Okay. So indeed, this one is how many dimensional surface?
4.
Yes. Okay, 4. Okay, 4. Then, can we visualize this? As I said, no. Okay, so we cannot visualize it. Okay. Then the same as before, we will have a domain and range. Domain is to think about x, y value because independent. Okay? So that is mean what are the possible values for x and y. So this one is domain. Okay? The possible value of z, this one we call range. Okay? The same as you learn in other course. So here I give an example, finish it, then we take a break. Okay? So the first one, square root of x plus y. Okay? So this, be careful, carefully is that sometimes I will give you a graph only, and I will say, you based on this view, based on if domain is like this, I want you to calculate what is the possible value of f, x, y. So I may give a domain by a graph. Okay? I may give a domain by a graph. So you should able to reverse. So this line is what? This line, how to show this relationship?
Y is equal to minus x.
Yeah, okay. So y is bigger than what? You draw any line. Okay? This one is minus 1 and 1. Okay? So it's upper area. So y is bigger equal than minus x. Okay? So this one is equal to x plus y bigger equal than 0. Okay? So actually it's the domain of the first one. Okay? Domain of the first one. So here I highlight. From this one, you draw that to the graph. It's easy. But you should able to do reverse. I give you a graph. You should know, write the equation for a graph. Okay? So the next one, this one means what? What? This is x, this is the origin, 0. So origin O, sorry, I always like to call 0. I should say O. This one is not 0, I should call origin. Okay, it's a O, okay. So in this case, you will have what? Positive x, positive y. Okay? So in this one, I should write what? Can you write one equation? No. Okay, you need to write 2. Okay, because you need 2 lines, so you have to say x bigger equal than 0, y bigger equal than 0. Okay, you need 2. Okay, you need 2 lines. Okay, no problem. Depend on how many lines. Okay. So the next one, this one. How many equations I need to show here? How many lines you have in the boundary? 1 line. Okay, 1 line. So in this case, you only need 1 equation for here. Okay, no problem. 1 equation for here. So actually, why this one use dash?
Is greater than 0.
Yes. Okay, greater than 0. So not include the boundary. Okay. So for the overall, actually it's just an equation of here. So this one is line minus x square plus, equal to plus 9y squared. Okay, so inside of this is what you should write 9 equal to, okay, x squared plus 3y squared. Okay, plus 3y here.
Also,
So-
like for example, that you have to define the domain implicitly, right?
Yes.
You cannot isolate one variable.
Yes. Okay. So no problem. Okay. So you need to write the reverse. Okay. Okay. That one is a. Indeed, later we will practice. Don't force yourself. Okay. Try to follow up. Okay. So indeed, some of the memory is needed, but I think if like this, I will give you some hint like. In the end, I will say what is the equation for overall, what is some things for what. I will give you some hint in the end, okay? So, but you need to find the parameter. I will reduce what you need a reference, but you should know what you to write, okay? As I say, all my recommend is I don't train you to be a computer, or I only want to teach you highlight the part ChatGPT cannot do, but what ChatGPT can do, let ChatGPT do. Okay? So in this sense, you need to tell the domain of like this. Okay? But you need to know how many equations you will define. Okay? And part in the parameter later I will know. So okay, so in this sense be careful. Okay? The next one, when we define explicit function and implicit function. Sorry, I said I will give a break, but finish this slide. Explicit is that you will exactly say z equal to something. So you will say z is dependent variable. Implicit is that you did not show which one is dependent variable, which one is independent. Okay? So in 2D, this one is explicit. Okay? You say y is dependent. So you use what? F is a function of independent variable. Okay, so we use small f. Okay, explicit equation with small f. But when you solve big F is implicit equation. So that is mean inside I include both dependent and independent. So separate small f and big F. Okay, they're different. Okay. Then the same. Okay, the first one explicit shows z. Okay, indeed you can say, can I say y equal to small f, xz? Yes. Okay. Then implicit use big F, x, y, z. Okay. Okay. What's the time now? 10. So you come around 50. Okay, 50. Okay, 10:50.
เปลี่ยนมุมมองในบทที่สอนให้ออเดอร์ตอนเดือนหน้าแล้วกันว่าจะส่งอาทิตย์หน้าเขาสอนโคตรจะว่าตั้งแต่ว่าเขาจะสอนเลยก็แสดงว่าต้องอ่านก่อนตอนหลังต้องสอนเลยครับคืออ่านเองแน่นอนแต่เขาต้องแบบบทหนึ่งก่อนแล้วใช้ออเดอร์ยูก็รู้ว่าที่นี่เป็นเองใช่ถึงที่นี่มันจะเที่ยงแค่ไหนเขาต้องมีแบบสอนที่เที่ยงก่อนแต่เขาจะสอนก่อนบทแล้วก็ส่งเลยก็ถ้าไม่อ่านนำก็ส่งก่อนมีปัญหาแต่ต้องพิมพ์นี่แหละถูกเวลาไปลงจริงชอบตอนนั้นนะ เขายังไม่ได้แบบโค้ดที่แบบลิงก์ให้ส่งแต่แล้วเราจะมีคลาวด์ซิสเต็มให้ส่งให้เขา
ใช่ข่าวน้อยมากเลยนะข่าวเขาให้แค่2-3 วันเองเมก
จริงๆมันแค่ส่ง PDF มันก็โอเคแล้วไฟล์มันไม่ส่ง2 เมกอยู่แล้ว
ก็ถูก
Well, this one is a solid
แต่
wall.
ที่ยังงงคือไงนะกลุ่มในการบ้านเขาคือเวลาที่พี่เคยมันต้องขึ้นกับพี่เคยถ้าเป็นแบบเรียกปกติมันไม่จำเป็นต้องใส่ไอ้ลิมิต2 ฝั่งแต่คราวนี้เขาบอกว่า assume ว่า the entire line ซึ่ง entire line มันนั่นแบบ all indefinite interval แต่เราไม่เขียนลบตีกูงงเลยหมายถึงว่าที่เขียน assume interval interest is the entire line ลบตีแล้วแบบถ้ามันทำเป็นลบตีมันก็ได้แบบตีมันก็0แต่ถ้าทำเป็นแบบ indefinite interval มันก็ควรจะติด4ซึ่งในชาร์ตมันไม่ติด4ในชาร์ตเขาไม่มี4ให้
เขาอาจจะคาดหวังให้เราแบบ
แบบยิบแบบไม่ต้องติด C เลยเหรอ
คือทุกอย่างนี้ไม่ไปสูงก็ไม่ได้จบ
ไม่ก็อย่างนี้แย่เลยนะอะไรก็มันคือ
เอาเป็นว่าไปก่อนไม่คาดหวังนะSure. อันนึงเป็นแบบในแบบวิทยาศาสตร์แบบผ่านเนื้อเยื่อแล้วแบบมาพออีกอันนึงก็ปลูกผักเขามีอีกอันนึงแค่แบบ